There's something both humbling and exhilarating about staring up at the night sky, isn't there? Every pinpoint of light holds a story, a mystery waiting to unfold. But among those countless stars and swirling galaxies, there's one cosmic wonder that stands out, a place where the rules of physics seem to bend, where the universe whispers its strangest secrets. Welcome to the Whirlpool Galaxy, also known as M51, a breathtaking spiral of stars and dust that's more than just a pretty face in the cosmos. This is a realm where the ordinary becomes extraordinary, where scientists have stumbled upon phenomena so bizarre, they challenge everything we think we know about space. And today, we're about to embark on a journey through 30 of its most mind-bending enigmas. Picture this, a galaxy so vivid, so dynamic, it feels almost alive. The Whirlpool Galaxy isn't just another speck in the telescope, it's a cosmic dance partner, locked in a gravitational embrace with a smaller companion galaxy. This interaction has sparked some of the most unusual events astronomers have ever witnessed. From freakish bursts of star formation to black holes behaving in ways that defy logic, M51 is a treasure trove of cosmic oddities. But here's the thing, the more we learn, the more questions we uncover. What's causing those eerie, unexplained radio signals? Why do some of its stars vanish without a trace? And what lurks in the shadows of its swirling arms just beyond our understanding? This isn't just a story about distant stars and cold, empty space. It's a reminder that the universe is far stranger, far more wondrous than we could ever imagine. And as we dive into these 30 mysteries, you'll start to see the Whirlpool Galaxy not as a static image, but as a living, breathing enigma, one that invites us to question, to wonder, and to keep searching for answers. So buckle up, because by the end of this journey, you'll never look at the night sky the same way again. At the heart of the Whirlpool Galaxy lies a puzzle that has left astronomers scratching their heads, not one but two bright cores glowing at its center. Most galaxies settle for a single nucleus, a crowded hub where stars and gas swirl tightly around a supermassive black hole, but M51 breaks the mold. Its second nucleus sits noticeably off-center, a brilliant anomaly that shouldn't exist under normal circumstances. So what's going on here? One leading theory suggests this cosmic oddity is the aftermath of a galactic dance gone wild. When the Whirlpool Galaxy's smaller companion, NGC 5159, swung too close, the gravitational tug of war may have ripped apart its core, scattering stars and gas in a chaotic trail. Some of that debris could have been snagged by the Whirlpool's pull, forming a second, makeshift nucleus like a stranger crashing a party and refusing to leave. But there's another, even wilder possibility, a pair of supermassive black holes circling each other in a slow, deadly waltz. Observations show intense X-ray flares erupting near the offset core, the kind of energy you'd expect from matter spiraling into a black hole's grasp. If true, this would mean the Whirlpool's heart hides not one, but two gravitational monsters, each warping space-time around it as they inch toward an eventual collision billions of years from now. Yet the mystery deepens. Some researchers argue the second nucleus might not be a core at all, but an illusion, a dense cluster of stars lit up by a sudden burst of star formation, mimicking the glow of a true galactic center. Without peering even closer, we're left to wonder, is this a cosmic doppelganger, a phantom, or something even stranger? What we do know is that the Whirlpool Galaxy refuses to play by the rules, and that's what makes it so fascinating. Just when you thought the Whirlpool Galaxy couldn't get any stranger, along comes ULX-7, an X-ray beacon so powerful, it defies everything we know about cosmic limits. Nestled in one of the galaxy's spiral arms, this ultra-luminous X-ray source shines hundreds of times brighter than any typical stellar black hole should. To put that in perspective, if a normal X-ray source were a flashlight, ULX-7 would be a stadium floodlight, blazing with enough energy to outshine entire star clusters. So what's powering this cosmic overachiever? One leading suspect is an elusive class of black holes we've barely begun to understand: intermediate mass black holes. These are the cosmic middleweights, bigger than the collapsed stars we call stellar black holes, but smaller than the supermassive giants lurking in galactic centers. If ULX7 harbors one of these rare objects, it could explain the extreme energy output. Picture a black hole with the mass of thousands of suns, greedily devouring gas and dust from a nearby companion star. As material spirals inward at near light speeds, it heats up to millions of degrees, unleashing those jaw-dropping X-ray flares. But here's where things get even weirder. Some astronomers argue ULX7 might not be a black hole at all, or at least not acting alone. Instead, it could be a neutron star, the dense corpse of a dead star, firing X-rays like a cosmic lighthouse. How? If the neutron star's magnetic field channels radiation into narrow beams, and one of those beams happens to point straight at us, we'd see an illusion of exaggerated brightness, like staring into a spotlight while missing the dimmer sides. Then there's the wild card. What if we're witnessing a whole new class of object? The Whirlpool Galaxy has a knack for serving up surprises, and ULX7's behavior doesn't perfectly fit any known model. It pulses with a bizarre rhythm, flickering on timescales that suggest something far more complex at play. Could it be a pair of objects in a tight orbit, or perhaps a black hole with a disk of material warped into strange shapes by extreme gravity? For now, every new observation only adds to the mystery, proving once again that the Whirlpool Galaxy is a master of cosmic misdirection. Among the Whirlpool Galaxy's many peculiarities, few are as visually striking as the ghostly gap in one of its majestic spiral arms. Gaze at any image of M51 and you'll notice something unsettling. A section of its grand design appears to have been erased, as if a cosmic hand swiped across the canvas, leaving behind a frayed edge. This isn't some trick of perspective or a flaw in the telescope. What we're witnessing is a galactic wound, evidence of a violent gravitational tug-of-war that's still unfolding. The culprit, the Whirlpool's smaller companion, NGC 5159. This dwarf galaxy hasn't just been a passive neighbor, it's been a disruptor, swinging in close enough to send shockwaves through M51's delicate spiral structure. Think of it like a pebble dropped into a spinning whirlpool, distorting the smooth flow of water. Over millions of years, the companion's gravity has pulled and stretched one of the whirlpool's arms, ripping away stars, gas, and dust, leaving behind a fragmented trail that astronomers call a phantom arm. But the damage isn't just cosmetic. This disruption has triggered a cascade of bizarre side effects. Inside the torn region, pockets of gas compressed by the gravitational turmoil have ignited a firestorm of new star formation. Young, blue hot stars blaze where the arm should be continuous, their intense radiation carving out bubbles in the surrounding dust. Meanwhile, the displaced material hasn't just vanished, it's been flung into the void between the two galaxies, forming eerie bridges of glowing matter. Some of these strands stretch tens of thousands of light years, tracing the path of the companion galaxy's destructive passage like cosmic breadcrumbs. Yet the most fascinating part isn't what's missing, it's what's hiding in plain sight. The phantom arm isn't truly gone. Radio telescope observations reveal tendrils of hydrogen gas, invisible to optical telescopes, still following the original spiral's curve. This ghostly remnant hints at the arm's former glory, a skeleton of its past structure lingering beneath the chaos. Astronomers now debate whether the Whirlpool spiral will eventually heal itself, smoothing out over eons, or if this gravitational assault has permanently altered its destiny. One thing's certain, the phantom arm is a testament to the violence hidden within the beauty of the cosmos, a reminder that even the grandest galactic designs are never set in stone. In the vast cosmic ballet of the Whirlpool Galaxy, some stars don't just dance, they flee. these aren't your everyday wanderers drifting lazily through space. These are hypervelocity stars, celestial speed demons rocketing outward at over 1,000,000 miles per hour, fast enough to escape the galaxy's gravitational grasp entirely. What cosmic slingshot could possibly hurl a star with such violence? The answer lies in the most extreme gravitational environments imaginable. At the heart of this mystery is the Whirlpool's dynamic duo, those twin supermassive black holes we glimpsed earlier. When a binary star system ventures too close to this pair, chaos unfolds. One star gets captured by a black hole's pull, while its companion is violently ejected like a pebble from a slingshot. Gravitational forces accelerate the doomed star to unimaginable speeds, sending it careening through the galaxy's spiral arms like a bullet through smoke. Some of these castaways reach velocities so high, they don't just leave their home behind, they punch straight through the Whirlpool's outer halo and into the void between galaxies, becoming cosmic orphans adrift in the darkness. But here's where it gets even more fascinating. These rogue stars carry clues about their origins imprinted in their light. Spectroscopic analysis reveals compositions rich in heavy elements, a telltale sign they were forged near the galactic center where star formation runs wild. Their trajectories, traced backward like cosmic breadcrumbs, often point directly to the Whirlpool's turbulent core, confirming their dramatic expulsion. Yet some paths twist unexpectedly, bent by encounters with dense gas clouds or the gravitational tug of other stars, leaving behind winding trails that puzzle astronomers. The implications are staggering. These hypervelocity stars aren't just galactic fugitives, they're intergalactic pioneers. As they cross the gulf between galaxies, they may seed distant regions with heavy elements, potentially triggering star formation in places where it shouldn't occur. Some might even survive long enough to be captured by another galaxy millions of years later, a cosmic immigrant with a violent past. And while most will wander forever, their journeys remind us that even in the vastness of space, nothing ever truly stands still. The Whirlpool Galaxy isn't just spinning, it's flinging pieces of itself into the unknown, one star at a time. Hovering at the edge of the Whirlpool Galaxy like a cosmic noose, a colossal loop of radio waves pulses silently across the void, an enigma wrapped in static. This isn't some faint smudge on an astronomer's scan. It's a structure spanning tens of thousands of light years, a ring of energy so vast it could swallow our entire Milky Way. And here's what makes it truly bizarre. This loop glows brightest in radio wavelengths, yet remains nearly invisible in optical light, as if the galaxy itself is whispering secrets only certain telescopes can hear. Theories about its origin split into two camps, each wilder than the last. One suggests we're witnessing the aftermath of a stellar apocalypse, a chain reaction of supernova so powerful their collective shockwaves blasted gas and magnetic fields outward like a tsunami. Picture a celestial fireworks finale where generations of massive stars lived fast, died young, and sculpted the surrounding space with their explosive final acts. Over millions of years, these overlapping detonations could have forged the loop as a fossilized bubble, a relic of the Whirlpool's most violent era of star birth. But there's a darker, more dramatic possibility. This loop might be a cosmic scar, the lingering echo of a primordial collision. Simulations show that when galaxies brush against each other, their gravitational turbulence can send shockwaves rippling through interstellar gas, compressing it into glowing, ring-shaped waves. If the Whirlpool's smaller companion galaxy once plowed through this region, the gravitational disturbance could have sent a supersonic ripple racing outward, like the wake of a ship but on an unimaginable scale. What defies logic, though, is the loop's persistence. Normally, structures like this should fade or dissipate within a few 100 million years, yet this one endures, its magnetic field still crackling with energy. Some researchers speculate it's being recharged by cosmic rays, high-speed particles from newer supernova zipping along its curves like cars on a celestial freeway. Others wonder if we're seeing something even rarer, the imprint of a jet from the galaxy's supermassive black hole, bent into a hoop by intergalactic winds. The loop's eerie silence in visible light deepens the puzzle. It's as though the Whirlpool Galaxy wrapped one of its arms in an invisible force field, a barrier we can only detect through the static hiss of radio waves. This disconnect hints at processes we've barely begun to understand, perhaps a phase of galactic evolution so peculiar we've never seen its like elsewhere. For now, the radio loop stands as a humbling reminder. Even in a galaxy we've studied for centuries, the universe still has cards up its sleeve. The Whirlpool Galaxy holds a secret in its invisible scaffolding, a skeleton of dark matter that doesn't behave the way it should. Dark matter, the mysterious substance that makes up most of a galaxy's mass, is supposed to form a smooth, spherical halo cradling the visible stars and gas. But M51 throws a cosmic curveball. Its dark matter is clumped and patchy, with baffling voids where it simply vanishes. These aren't minor irregularities, they're gaping holes in our understanding of how galaxies are built. Peering into these dark matter deserts, astronomers face a glaring question. How can a galaxy so beautifully structured lack the gravitational glue that should hold it together? One clue comes from the Whirlpool's turbulent past. When it began its gravitational tango with its companion galaxy, the collision may have ripped through the dark matter halo like a bullet through fog, scattering particles into odd configurations. Simulations show such encounters can stretch dark matter into long, tendril-like filaments or punch empty cavities where the two galaxies' halos cancel each other out. Think of it like two whirlpools merging in water. The resulting currents don't just blend smoothly, they create chaotic eddies and dead zones, yet there's a twist that defies even this explanation. Some of the gaps align perfectly with regions where the whirlpool's spiral arms shine brightest. This inverse relationship, visible matter thriving where dark matter falters, hints at something far stranger. Could dark matter interact with itself in ways we haven't accounted for? Most models assume it's cold and collisionless, passing through itself like ghosts in the night. But if dark matter particles occasionally bump or repel each other, it might explain why they've retreated from areas dense with stars, as if making room for the luminous universe. The implications ripple far beyond M51. If dark matter isn't distributed as predictably as we thought, entire theories of galactic formation might need rewriting. Planets, stars, even life itself exist because dark matter's gravity sculpted the cosmos. But what if its role is more dynamic, more reactive than we imagined? The Whirlpool's patchy halo suggests dark matter could be swayed by the very structures it helps create, locked in a feedback loop we're only beginning to decipher. For now, every new observation deepens the mystery. Some telescopes hunt for faint gamma rays, hoping to catch dark matter particles annihilating at the edges of those gaps. Others map the galaxy's gravitational, lensing the way its mass bends light from background objects to reconstruct its invisible architecture in higher detail. Each dataset paints a weirder picture, proving that even the darkest corners of the universe refuse to stay silent. The Whirlpool's missing dark matter isn't just an anomaly, it's a cosmic invitation to rethink the rules. Deep within the Whirlpool Galaxy's spiral arms, nature's most spectacular explosions are on a production line. This cosmic pinwheel isn't just forming stars, it's detonating them at a pace that leaves astronomers baffled. While most galaxies average one supernova every century, M51 has unleashed at least 5 in just the past 70 years, including the infamous SN 2005 CS, a stellar blast so bright it outshone billions of stars combined. What's turning this galaxy into a supernova factory? The answer lies in its restless, star-birthing heart. The Whirlpool's spiral arms aren't just pretty swirls, they're pressure cookers. Here, clouds of gas collide and compress under the gravitational strain of the galaxy's dance with its companion, NGC 5159. This chaos births massive stars at a frenzied rate, each one a ticking time bomb. Stars 8 times heavier than our Sun live fast and die young, burning through their fuel in mere millions of years before collapsing in catastrophic explosions. But the whirlpool's true eccentricity is where these supernovae keep appearing, not scattered randomly but clustered in bizarrely active pockets. One region alone, near a dense knot of gas dubbed the firestorm cluster, has produced 3 supernovae in 20 years, a statistical anomaly that defies the odds. SN 2005 CS offered scientists a front-row seat to this pyrotechnic display. Classified as a Type II supernova, it began as a red supergiant star quietly fusing elements in its core until the fusion furnace sputtered. Without outward pressure to counteract gravity, the star's own weight crushed it inward at a quarter the speed of light, then rebounded in a shockwave that tore the star apart. For weeks, the blast glowed with the energy of 100 million suns, its light curve revealing something peculiar, traces of hydrogen far thicker than most supernova ejecta. This suggests the dying star was shrouded in dense gas, possibly ejected in violent convulsions before its final act, an encore performance unique to the Whirlpool's unstable stellar nursery. Yet the real mystery isn't the explosions themselves, but the chain reaction they've ignited. Each supernova shockwave slams into nearby gas clouds, squeezing them until new stars ignite, some destined to explode in turn. It's a self-perpetuating cycle, like a cosmic game of dominoes where every collapse sets up the next. Radio telescopes have even detected eerie supernova echoes in the whirlpool rings of dust illuminated years after the initial blast by lingering light, proving these explosions reshape their environment long after the fireball fades. Could this feedback loop explain the galaxy's relentless output? Possibly, but there's a twist. The Whirlpool's supernova rate still exceeds predictions, even accounting for its star-forming frenzy. Some theorists speculate hidden factors are at play, perhaps a surplus of binary star systems where one star's death triggers its partner's explosion, or unseen dark matter densities subtly tweaking the galaxy's gravitational recipe. Whatever the cause, one thing's clear: the Whirlpool doesn't just host supernova. It engineers them, crafting stellar deaths with a frequency that challenges our understanding of galactic life cycles. And with every new detonation, it offers astronomers another piece of the puzzle written in the fleeting glow of a star's final breath. The Whirlpool Galaxy hides another cosmic secret, this one written in the faint, ghostly glow of infrared light. Surrounding its spiral arms like an ethereal shroud, an enormous halo of infrared radiation pulses with unexplained energy. This isn't just scattered starlight or background noise. It's a structured, persistent emission that defies conventional explanations. Most galaxies have some infrared signature from warm dust, but the Whirlpool's halo is brighter, wider, and far more enigmatic than anyone predicted. What's powering this radiant anomaly? The answers might rewrite what we know about galactic ecosystems. One leading theory points to an invisible army of rogue star clusters. Beyond the galaxy's visible disk, there could be swarms of young, massive stars born in the chaos of past galactic collisions. These stellar runaways, ejected by gravitational encounters, heat surrounding dust to extreme temperatures, causing it to glow in infrared. Picture a galactic diaspora, stars flung into the darkness, still burning fiercely enough to illuminate their own dusty cocoons. Telescopes have spotted hints of such clusters in other galaxies, but the Whirlpool's halo is on another scale entirely, suggesting a stellar exodus of unprecedented magnitude. Then there's the darker, more speculative possibility: exotic particle interactions. Some astrophysicists argue the infrared excess might trace the presence of weakly interacting massive particles, or WIMPs, hypothetical dark matter candidates that could annihilate each other, releasing energy as they collide. If dark matter is concentrated in the Whirlpool's outer halo, these phantom particles might be decaying or colliding. Their death throws heating dust grains to infrared-emitting temperatures. It's a long shot, but if proven, it would be the first indirect detection of dark matter's hidden physics, with the Whirlpool as our cosmic laboratory. Yet the plot thickens when we examine the halo's structure. Unlike the smooth, diffuse glow expected from simple dust heating, this one shows intricate filaments and asymmetries, like cosmic fingerprints left by some unseen hand. Radio telescope data reveals magnetic fields threading through the halo, their lines twisted into bizarre configurations that suggest turbulent histories. Could galactic winds powered by supernova or the central black hole be sculpting this emission? Or is the Whirlpool's companion galaxy stirring the pot, its gravitational nudges compressing gas and dust into glowing ridges? The most tantalizing clue comes from the halo's spectrum, the unique fingerprint of its light. Certain wavelengths spike unexpectedly, indicating molecules like polycyclic aromatic hydrocarbons, complex carbon compounds typically found in star-forming regions. But here, they float far from any obvious stellar nurseries, like smoke lingering after a fire that's long since burned out. This suggests the Whirlpool's halo isn't just a static feature but a dynamic record of its past, a graveyard of ancient starbursts or the echoes of a violent merger millions of years ago. What makes this infrared enigma so compelling isn't just the mystery itself, but what it reveals about galaxies as living systems. The Whirlpool isn't an island of stars in empty space. It's a breathing entity, constantly exchanging matter and energy with its surroundings. That faint infrared glow might be the signature of processes we've barely begun to understand, a hidden layer of galactic life, invisible to our eyes but blazing in the language of heat and dust. And until we peer deeper, the halo remains a cosmic koan, challenging us to rethink where a galaxy truly ends and the void begins. Tucked away in the Whirlpool Galaxy's outer fringes, a cosmic afterthought drifts silently, an unassuming knot of stars and gas that shouldn't exist. Designated as M51's tidal dwarf galaxy candidate, this clump of celestial leftovers might just rewrite the rules of galactic evolution. Unlike traditional dwarf galaxies, which form in the primordial soup of the early universe, this one appears to have been stitched together from the debris of a gravitational brawl. The Whirlpool's violent tango with its companion, NGC 5159, didn't just warp spiral arms, it may have birthed an entirely new galaxy from the wreckage. Close inspection reveals why this object defies expectations. Most dwarf galaxies are dominated by dark matter, their stars clinging to an invisible scaffold of mysterious mass. But spectroscopic analyses of this candidate tell a different story. Its rotation speeds and stellar motions suggest it's running on star power alone, gas and stars with hardly any dark matter at all. That's like finding a car speeding down the highway without an engine. Conventional physics says it shouldn't move this way, the leading explanation. This isn't a primordial dwarf, but a rebel offspring forged from material ripped free during the Whirlpool's gravitational encounters. The smoking gun lies in its chemical fingerprints. The candidate stars are rich in heavy elements like oxygen and iron, traces of a violent origin. When the Whirlpool's spiral arms were stretched and shredded, pockets of gas collided with such force that they ignited starbirth on overdrive. Over eons, supernova from those stars salted the region with metals, creating the oddball chemistry we see today. It's as if the galaxy's dance left behind a scrap metal sculpture, glowing defiantly against the void. Yet controversy lingers. Some researchers argue the object might just be a particularly dense spiral arm fragment, a temporary structure destined to dissolve back into the Whirlpool's embrace. Others point to its stable, rounded shape, unusual for a mere debris cloud, as evidence of true galactic independence. The debate hinges on a critical question: can a galaxy truly form without dark matter's gravitational glue, or are we witnessing a cosmic mirage? What's undeniable is the candidate's defiance. If confirmed, it would prove galaxies can emerge not just from the universe's infancy, but from the chaos of later collisions. Every telescope trained on it is looking at a potential revolution, a glimpse into how the universe repurposes its wreckage into something new. The Whirlpool's tidal dwarf candidate isn't just a curiosity. It's a challenge to our cosmic classification systems, whispering that even the smallest outliers can hold the biggest surprises. Amid the Whirlpool Galaxy's swirling arms, a patch of space crackles with invisible fury, a gamma-ray hotspot so intense it outshines the rest of the galaxy combined. These aren't your everyday cosmic rays. Gamma rays pack enough punch to slice through lead, born from the universe's most violent events. Yet here's the twist: scan the hotspot with optical or radio telescopes and you'll find nothing. No visible star cluster, no black hole fireworks, not even a supernova remnant. It's as if the universe flipped a switch, flooding this patch of space with lethal energy while leaving no trace of the power source. One explanation points to a hidden graveyard of pulsars, the spinning corpses of dead stars. When massive stars collapse, their cores can become ultra-dense neutron stars, spinning hundreds of times per second and shooting beams of radiation like cosmic lighthouses. If dozens of these pulsars crowd the hotspot, their combined gamma-ray glow might explain the emission. But there's a problem. Pulsars usually flicker with predictable rhythms, and this hotspot burns steady like a bonfire with no smoke. Then there's the dark matter angle. Some theories suggest dark matter particles, when they collide, could annihilate each other in bursts of gamma radiation. The Whirlpool's halo, with its clumpy dark matter distribution, might harbor dense pockets where these collisions run rampant. It's a tantalizing idea, except no one's ever caught dark matter in the act of annihilating, leaving the theory hovering between breakthrough and wishful thinking. The wild card: cosmic rays caught in a natural particle accelerator. Galactic magnetic fields can whip charged particles to near light speeds, and when these particles slam into gas clouds, they spawn gamma rays as a byproduct. The Whirlpool's turbulent arms, with their shockwaves from supernova and colliding gas, could be running a cosmic-scale version of the Large Hadron Collider. Yet even this doesn't quite fit. The hotspot's energy spectrum shows spikes at particular wavelengths, hinting at something more structured than random collisions. Perhaps the most unsettling possibility is that we're seeing a composite of all three, a cosmic masquerade where pulsars, dark matter, and accelerated particles each contribute to the glow. Or worse, something entirely new. The hotspot's persistence defies easy categorization, a reminder that the universe often reserves its deepest secrets for those willing to sit with the unknown. For now, it remains a beacon of our ignorance, pulsing at the edge of understanding. The Whirlpool Galaxy plays a cruel game of cosmic hide and seek with its hydrogen gas. One moment, vast clouds glow brilliantly in radio telescopes, and the next, they've vanished without a trace. These aren't small, wispy tendrils. We're talking about reservoirs of gas so massive they could fuel star formation for millions of years, blinking in and out of visibility like a flickering neon sign. What kind of interstellar sleight of hand could make something so substantial disappear? The answer might lie in the delicate balance between light and shadow on a galactic scale. Hydrogen, the universe's most abundant element, usually announces its presence with a telltale radio signature, a faint hum at 21 centimeters wavelength emitted when its atoms shift energy states. But in the Whirlpool, certain regions that should be bustling with this signal go eerily silent. One leading theory suggests these clouds aren't truly vanishing. They're being ionized, stripped of their electrons, by an invisible barrage of ultraviolet radiation. Imagine a fog bank suddenly lit by a spotlight so intense the droplets evaporate, leaving clear air. In this case, the spotlight comes from clusters of young, scorching hot stars hidden within the galaxy's spiral arms. Their intense UV light could be splitting hydrogen atoms apart faster than telescopes can detect them, rendering the gas invisible until it cools and recombines. Yet there's a catch. Some of these disappearing acts occur far from any known star-forming regions, in zones too quiet to host such energetic stellar nurseries. That's led astronomers to propose an even stranger culprit: vast, dark structures woven from cold molecular gas. These stealthy formations, dense enough to block radio waves but too cold to emit much light of their own, might be absorbing the hydrogen signal like a cosmic sponge. Picture trying to spot a lighthouse through thick fog. The beam is still there, but something in between is swallowing the evidence. Supporting this idea, infrared telescopes have glimpsed shadowy filaments in these zones, hinting at reservoirs of material our other instruments can't fully penetrate. The plot thickens when you consider timing. Some of these clouds don't just vanish, they fade gradually over months or years, then reappear just as slowly, as if the galaxy itself is breathing. That's far too quick for traditional stellar processes, suggesting something more dynamic is at play. Could magnetic fields be twisting through these regions, temporarily trapping ionized gas in configurations that mute its radio hum? Or are we witnessing the aftermath of collisions between gas clouds, where shockwaves temporarily disrupt hydrogen's ability to broadcast its presence? Each scenario paints the Whirlpool as a galaxy alive with unseen turbulence, its apparent serenity masking a constant churn of creation and destruction. What makes these disappearing clouds so fascinating isn't just their mystery, it's what they reveal about the limits of our cosmic perception. The Whirlpool reminds us that even the most advanced telescopes don't show the full picture. They capture slices of reality filtered through wavelengths we've learned to decode. Every time one of these hydrogen clouds winks out, it's a silent challenge daring us to ask, how much of the universe's ordinary material is hiding in plain sight, reshaped by forces we've yet to comprehend? Until we solve this riddle, the Whirlpool's vanishing acts will remain one of its most humbling enigmas, a reminder that in the grand theater of the cosmos, even the simplest elements can master the art of illusion. The Whirlpool Galaxy might be hiding one of the rarest galactic accessories ever discovered: a polar ring, a halo of stars and gas rotating at a near-perfect right angle to the main disk. Most galaxies spin like plates on a table, their stars and gas moving in a flat, orderly plane. But a polar ring galaxy breaks all the rules, wrapping itself in a cosmic belt that orbits over its poles instead of its equator. If confirmed, this would make M51 part of an exclusive cosmic club. Fewer than one in every 1,000 galaxies displays this peculiar architecture. So how does a galaxy end up wearing such a bizarre ornament? The leading theory involves a high-speed celestial heist. Picture this: billions of years ago, the Whirlpool Galaxy brushed past a smaller, gas-rich neighbor. As they grazed each other, gravity yanked a river of material from the victim galaxy, flinging it into a lopsided orbit. Over eons, this captured debris settled into a perpendicular ring, like smoke rings blown at right angles to a spinning wheel. Computer simulations show these encounters can produce exactly the kind of off-kilter structures we're now glimpsing in the Whirlpool's outer reaches. But the evidence isn't just theoretical. Radio telescopes have detected streams of hydrogen gas arcing far above the galaxy's disk, moving at velocities that defy the plane of rotation. Even more telling, certain star clusters in the Whirlpool's halo orbit at extreme inclinations, their paths tracing the ghostly outline of a disintegrating ring. The strangest part, these stars are chemically distinct from the rest of the galaxy, older, with fewer heavy elements, as if they were kidnapped from a more primitive galaxy that met its demise long ago. Yet the polar ring theory faces skepticism. Some researchers argue these oddball orbits might simply be the stretched remnants of the Whirlpool's ongoing dance with NGC 5159, not a true ring structure. Others suggest we're witnessing the last gasps of a failed merger, where the companion galaxy came in at such a steep angle that its debris never fully settled into the disk. The clincher would be finding a complete loop of material encircling both galactic poles, something no telescope has yet confirmed. If real, this polar ring isn't just a cosmic curiosity, it's a time capsule. The gas and stars within it could preserve the chemical fingerprints of the Whirlpool's ancient environment, offering clues about galactic interactions we can't observe directly. Even more compelling, polar rings are notorious for sparking bursts of star formation where their tilted orbits intersect the main disk, creating fireworks of stellar birth. The Whirlpool's spiral arms already blaze with young stars. Could some of that activity be fueled by this hidden, perpendicular pipeline of gas? For now, the polar ring remains a tantalizing maybe, a shadowy structure flickering at the edge of detection. But whether it's a full ring or just a fragmentary relic, its presence would prove the Whirlpool's history is even more violent and complex than we imagined. A galaxy that didn't just grow quietly, but stole pieces of its identity from passing strangers, wearing their remains like a crown. Amid the Whirlpool Galaxy's vibrant spiral arms, where blue-white young stars typically dominate, there's an oddity that shouldn't belong: patches of ancient, reddish stars scattered like cosmic fossils. These red and dead zones stand in stark contrast to their surroundings, their dim glow hinting at stellar populations billions of years older than the Whirlpool's dynamic spiral structure. How did these elderly stars end up in a galaxy otherwise bursting with youth? The answer may lie in the Whirlpool's violent past, a history written in the unlikeliest of ink, the quiet light of aged suns. These anomalous red stars aren't just passively lingering, they're clues to a forgotten collision. Most spiral galaxies like M51 form stars continuously, their arms glowing blue with hot, newborn stars. But the red patches suggest something different, a fragment of an older galaxy, swallowed whole during a long-ago merger. When galaxies collide, their stars don't crash together like bumper cars, they slip past each other, weaving new orbits from the chaos. The heaviest, metal-rich stars from the victim galaxy often sink toward the center, while lighter, older stars get strewn like breadcrumbs along the edges. That's why these red stars cluster in peculiar, off-kilter patterns, their distribution defying the Whirlpool's otherwise orderly rotation. Yet the mystery deepens when we study their chemistry. Spectroscopy reveals these stars are deficient in heavy elements: iron, silicon, carbon compared to the Whirlpool's native populations. This metal-poor signature is the smoking gun. They originated in a smaller, older galaxy that never had the intense star formation needed to forge heavier elements. When this primitive galaxy was torn apart and absorbed, its stars became interlopers in a younger, metal-rich environment, like finding a tribe of ancient humans living in a modern city. The most intriguing red zones hover near the Whirlpool's outer arms, far from where merger debris should settle. One explanation involves dynamic friction, a gravitational tug of war where dense star clusters slowly spiral inward over eons, leaving behind stragglers in unexpected places. Another theory posits that these stars were flung outward during the merger's most violent moments, slingshotted to the galaxy's fringes by gravitational waves. Either way, their presence reveals a hidden truth. The Whirlpool wasn't always the majestic spiral we see today. It's a cannibal, a cosmic quilt stitched together from galactic remnants. What makes these red anomalies particularly valuable is their silence. Unlike supernova or black holes, they don't scream for attention, they whisper. Their steady, unchanging light preserves a record of the Whirlpool's formative violence, unaffected by the drama of newer stars. By mapping their positions and motions, astronomers can reconstruct the trajectory of the ancient collision, like forensic scientists tracing bullet paths to solve a crime. The red and dead patches aren't just relics, they're active participants in the Whirlpool story. Recent studies suggest their gravity may subtly warp the orbits of younger stars nearby, creating ripples in the spiral arms we've only begun to detect. Even in retirement, these ancient stars shape their adopted home, proving that in galaxies as in life, the past never truly fades, it just fades to red. The Whirlpool Galaxy's magnetic field isn't just a backdrop, it's a cosmic tempest, twisting and snapping in ways that leave physicists stunned. Most spiral galaxies boast orderly magnetic fields, their lines flowing smoothly along the arms like grooves in a vinyl record. But M51's fields are tangled, warped, and at times downright rebellious. Some regions flare with magnetic energies 100 times stronger than our Milky Ways, while others collapse into eerie voids where the field all but vanishes. This isn't just random chaos, it's a signature of forces wilder than we ever imagined. The first clue to this pandemonium came from radio telescopes. By tracking polarized light from cosmic rays spiraling along magnetic field lines, astronomers mapped the whirlpool's invisible scaffolding and found it in disarray. Near the galaxy's core, the field coils into tight helices as if wrung by an invisible hand. Out in the arms, it fractures into jagged filaments, some stretching tens of thousands of light years before abruptly kinking or fraying. The most bizarre distortions cluster where the Whirlpool's companion galaxy passed closest, suggesting gravitational tides didn't just stir stars and gas, they scrambled the galaxy's magnetic DNA. But gravity alone can't explain the full spectacle. Supernova add fuel to the fire. Each dying star's shockwave punches through the interstellar medium, twisting nearby field lines into knots like a spaghetti tangle. In the Whirlpool's star-birthing arms, these explosions come in relentless waves, creating a feedback loop where turbulence begets more turbulence. Simulations show that under such conditions, magnetic fields can amplify themselves, stealing energy from galactic rotation to grow ever stronger, a self-sustaining storm that might explain those freakish energy spikes. Then there's the dark horse, cosmic rays. These high-speed particles, accelerated by supernova or black holes, don't just passively ride magnetic fields, they reshape them. Like needles threading through fabric, cosmic rays drag field lines along their paths, creating bizarre structures like the magnetic chimneys, observed in the Whirlpool's halo tunnels where fields funnel particles outward, as if the galaxy itself were venting steam. Yet the biggest enigma isn't the turbulence, it's the patches of eerie calm. Amid the chaos, some regions show fields aligned with near-perfect symmetry, as if shielded by an unseen force. One theory points to dense molecular clouds, their icy interiors shielding fields from external disruption. Another suggests these orderly zones are fossil traces of the galaxy's original pre-collision magnetism, preserved like flies in amber. What makes these magnetic contortions so pivotal is their ripple effect. Fields this wild don't just decorate space, they engineer it. By channeling gas flows, they dictate where stars can form. By trapping cosmic rays, they sculpt the galaxy's radiation climate. Some researchers even speculate that the Whirlpool's twisted fields might be seeding its spiral arms, their tension helping maintain those iconic swirls against the pull of time and gravity. In the end, the Whirlpool's magnetic tantrums are more than a curiosity, they're a masterclass in galactic evolution. Most telescopes show us the universe in light and shadow, but magnetism reveals the hidden currents that truly shape a galaxy's destiny. And as we decode its frenzied patterns, we're not just mapping fields, we're reading the Whirlpool's autobiography, written in the invisible ink of a force that refuses to play by the rules. Hovering like spectral balloons above the Whirlpool Galaxy's vibrant disk, two colossal gamma-ray bubbles stretch into the void, each one a faint, gargantuan structure spanning tens of thousands of light years. These aren't mere afterthoughts in the galaxy's anatomy, they're among the most puzzling features ever observed. Imagine flipping a cosmic hourglass and watching its sands glow with the energy of a million suns. Except here, the sands are invisible particles and the hourglass is suspended in space, silent and enigmatic. These gamma-ray bubbles echo similar structures in our own Milky Way, known as Fermi bubbles, but the Whirlpool's versions are far more mysterious. Unlike their Milky Way counterparts, which align neatly with the galactic core, M51's bubbles tilt at odd angles, as if some ancient eruption punched through the galaxy at a skew. Even stranger, their gamma-ray signature pulses with irregularities. Hotspots flicker on and off, while vast swaths remain eerily dark. Whatever created these bubbles didn't just explode, it left behind a fingerprint of chaos. The leading theory points to the Whirlpool's supermassive black hole. When black holes feed voraciously, they don't just swallow matter, they belch out titanic jets of energy. If the central black hole experienced a feeding frenzy millions of years ago, its jets could have tunneled through the galaxy's halo, inflating these bubbles like cosmic bellows. But there's a catch. The Whirlpool's bubbles don't show the symmetrical, bipolar structure typical of black hole outbursts. Instead, they're lopsided, suggesting the black hole might have hiccuped rather than roared, spraying energy unevenly into space. Alternatively, the bubbles could be relics of a starburst apocalypse. If the Whirlpool's core once hosted a frenzied wave of supernova, their combined shock waves might have blown a cavity in the surrounding gas, accelerating particles to near light speeds. These high-speed particles, colliding with the galaxy's magnetic fields, would then emit the gamma rays we detect today. Yet this explanation falters when faced with the bubble's sheer scale. Could even the most violent star-forming episode produce structures this vast? The most tantalizing clue lies in the bubble's composition. Embedded within their faint glow are traces of antimatter, the universe's most elusive substance. When matter and antimatter meet, they annihilate in bursts of gamma radiation. Some theorists speculate the bubbles might be threaded with veins of antimatter, sewn into their fabric by processes we've yet to understand. Could dark matter be decaying here, producing antimatter as a byproduct? Or are we seeing the aftermath of a runaway chain reaction, where high-energy photons spontaneously spawn matter-antimatter pairs? Compounding the mystery, the bubbles aren't static. Over the past decade, subtle shifts in their gamma-ray emissions hint at underlying currents, almost as if they're breathing. Some regions brighten while others dim, suggesting an invisible interplay between particles and magnetic fields. It's a dynamic puzzle, one that challenges our assumptions about how galaxies distribute energy into their surroundings. These ghostly structures serve as a humbling reminder. Even the most familiar cosmic phenomena can harbor secrets. The Whirlpool's gamma-ray bubbles aren't just celestial decorations. They're a window into the galaxy's most violent chapters, written in a language of light we're still learning to decipher. And until we crack their code, they'll linger above the Whirlpool like cosmic question marks, silent witnesses to forces beyond our current grasp. The Whirlpool Galaxy doesn't just birth stars, it does so in violent, unpredictable bursts, like a cosmic engine sputtering between extremes. One moment, its spiral arms blaze with the light of newborn stars, and the next they fall eerily silent, as if someone flipped a switch. These starburst hiccups defy the steady rhythm of star formation we see in most galaxies, and the culprit might be lurking just next door. The Whirlpool's unruly companion, NGC 5159, whose gravitational meddling could be strangling the galaxy's gas supply on a cosmic schedule. Take the great starburst of 20 million years ago, a frenzy so intense it lit up the Whirlpool's core with the fire of 100 million suns. Telescopes have spotted the aftermath, vast bubbles of hot gas still expanding from that era, their surfaces studded with the blue glare of young star clusters. Yet dig deeper, and you'll find layers of older, dimmer stars beneath, evidence of an earlier quiet period. This boom and bust cycle isn't just random chaos, it's a telltale sign of a galaxy struggling to regulate its own growth. The key lies in the gas, the lifeblood of star formation. Normally, spiral galaxies like the Whirlpool funnel gas smoothly inward along their arms, feeding a steady trickle of star birth. But NGC 5159 throws a wrench into the works. Every time it swings close on its elongated orbit, its gravity tugs at the Whirlpool's gas reservoirs, disrupting the inflow like a child splashing in a stream. Some simulations show these encounters briefly compressing gas clouds, triggering starbursts as sudden as a thunderclap. Then, as the companion galaxy retreats, it drags gas away with it, leaving the Whirlpool star factories starved and silent. What's bizarre is the precision of these disruptions. The quiet periods aren't just gaps, they're oddly uniform, some lasting roughly 50 million years before the next burst ignites. That regularity hints at something deeper, a resonance between the two galaxies' orbits, a gravitational syncopation that amplifies the disruptions. Think of it like pushing a swing at just the right moment to make it go higher, except here, the push steals gas instead of adding energy, and the swing is an entire galaxy's star-forming rhythm. Yet even this explanation doesn't cover the full picture. Some starbursts erupt in patches rather than galaxy-wide, suggesting local instabilities like gas clouds collapsing under their own weight can override the grand gravitational ballet. And then there's the wild card, supernova from previous starbursts. These explosions can carve out cavities in the gas, delaying future star formation until enough material drifts back in. It's a cosmic feedback loop where the galaxy's own fireworks silence its next act. The Whirlpool's starburst hiccups aren't just a curiosity, they're a preview of our cosmic future. As the Milky Way and Andromeda galaxies merge billions of years from now, they too may experience these violent bursts and lulls. For now, though, the Whirlpool serves as a living laboratory, its erratic heartbeat reminding us that even the grandest galaxies don't grow smoothly. They sputter, gasp, and reignite, dancing to the messy rhythm of gravity's whims. Scattered like sapphire fireflies against the Whirlpool Galaxy's grand spiral tapestry, a handful of stars blaze with an impossible hue, deep blue, radiant, and utterly out of place. These aren't just young, hot stars, they're cosmic misfits, their chemistry betraying a secret they shouldn't possess. Nestled far from the galaxy's metal-rich core, these blue outliers shine with heavy elements like iron and gold at levels 10 times higher than their neighbors, as if a gourmet chef somehow wound up in a fast food kitchen. Their existence isn't just unlikely, it's a flagrant violation of galactic norms, and the explanation might rewrite how we understand stellar eviction. Galaxies typically follow a strict metallicity gradient. Stars near the center, forged from gas enriched by countless supernova, are rich in heavy elements, while those farther out are more pristine, preserving the early universe's simpler chemistry. But the Whirlpool's blue outliers flout this rule with audacious brilliance. Spectroscopy reveals their atmospheres are laced with elements like platinum and europium, traces of a violent origin near the galactic center, where supernova and neutron star collisions forge these rarities. So how did they end up exiled to the galactic suburbs? The leading theory involves the Whirlpool's chaotic core. Picture a stellar pinball machine where gravitational kicks from the twin supermassive black holes can launch stars into hyperspace. When binary star systems wander too close, one star might get captured while its partner is ejected at mind-bending speeds, up to 2 million miles per hour. These hypervelocity stars carry their metallic fingerprints with them, streaking across the galaxy until they settle in regions where their chemistry makes no sense. The blue outliers could be the survivors of such a cosmic slingshot, their journey lasting millions of years before they flared to visibility in their new, incongruous homes. But there's a twist. Some of these stars aren't just metal-rich, they're also spinning wildly, their surfaces churning with turbulence that suggests a traumatic past. This hints at another possibility. They might be merger remnants, the smoldering wreckage of two smaller stars colliding near the core before being flung outward. Imagine two hot, metallic-rich stars spiraling into each other, their fusion creating a single, blue-hot monstrosity that's then hurled into the galactic hinterlands by a black hole's gravity. The result, a stellar grenade, its shrapnel glowing with the chemistry of a place it no longer belongs. The most perplexing outliers, though, cluster in a loose arc along one spiral arm, a pattern that suggests they weren't ejected randomly but as part of a cohesive event. Radio telescopes have spotted faint trails of ionized gas leading back toward the core, like breadcrumbs from a stellar crime scene. This implies something even more dramatic, a failed tidal disruption, where the Whirlpool's black holes nearly shredded a dense star cluster, only to spit its remnants outward in a coordinated burst. If true, these blue stars aren't just runaways, they're refugees from a near catastrophe, their chemistry a testament to the carnage they escaped. What makes these outliers so invaluable isn't just their defiance of expectations, it's the stories they carry. Each one is a time capsule, preserving a snapshot of the Whirlpool's most violent moments. By decoding their light, we're not just studying stars, we're reconstructing gravitational upheavals that occurred long before humans gazed at the night sky. They remind us that galaxies aren't static museums, they're kinetic sculptures, where even the most distant stars might hold the scars of a riotous past. And as we map their journeys, we're left to wonder, how many other cosmic fugitives are hiding in plain sight, their origins written in light we've yet to decipher? The Whirlpool Galaxy holds a curious emptiness where there should be bustling cities of stars. Its population of ancient globular clusters is shockingly sparse. These dense balls of stars, each packed with hundreds of thousands of stellar residents, are cosmic relics from the universe's infancy, found by the dozens in most large galaxies. Yet surveys of M51 reveal fewer than half the expected number, leaving astronomers to wonder, did the Whirlpool lose them, or were they never there to begin with? One clue lies in the cluster's peculiar distribution. While most galaxies anchor their globulars in a spherical swarm around the core, the Whirlpool's survivors huddle close to its spiral disk as if clinging for dear life. This odd arrangement suggests a history of gravitational purging. When galaxies collide, the chaos can strip away loosely bound clusters, flinging them into intergalactic space like pebbles shaken from a sieve. Given the Whirlpool's violent dance with its companion, it's plausible that countless clusters were ejected over billions of years, their faint trails now lost in the void. But there's a hitch: some missing clusters might have met a darker fate. The Whirlpool's twin black holes could act as cosmic shredders. As globular clusters stray too close, tidal forces might rip them apart, scattering their stars into the galactic halo. Computer simulations show black hole pairs are especially efficient at this demolition, their combined gravity creating chaotic orbits that tear clusters apart from within. The evidence, a smattering of orphaned stars in the Whirlpool's outer reaches, moving in patterns that hint at a dismantled cluster's remains, yet not all researchers blame destruction. An alternative theory suggests the Whirlpool never formed many globulars to begin with. These clusters thrive in metal-poor environments where pristine gas allows them to coalesce early. But if the Whirlpool's progenitor was unusually metal-rich, perhaps from prior mergers, it might have stifled cluster formation from birth. Supporting this, the surviving globulars are paradoxically younger than expected, their chemical makeup revealing they formed later than counterparts in other galaxies. The implications stretch beyond mere star counts. Globular clusters are time capsules; their ages and compositions chronicle a galaxy's earliest epochs. Their absence in the Whirlpool leaves gaps in that history, like missing pages from a cosmic diary. Did the galaxy's turbulent youth erase them, or did something about its birth prevent their creation? The answer might rewrite how we understand galactic adolescence, showing that even the grandest spirals can emerge from wildly different childhoods. For now, those silent gaps in the Whirlpool's starry tapestry remind us sometimes what's missing speaks louder than what remains. The Whirlpool Galaxy doesn't just simmer with starlight, It crackles with invisible tsunamis, waves of high-energy particles surging through its spiral arms with enough force to reshape entire regions of space. These cosmic ray tsunamis are no gentle ripples. They're shock waves of protons and atomic nuclei, accelerated to nearly the speed of light, battering gas clouds and magnetic fields like a relentless interstellar storm. What cosmic catapult could launch particles with such ferocity? The answer might lie in the aftermath of destruction, supernova remnants and black hole jets, the galaxy's most violent architects. When a massive star explodes as a supernova, it doesn't just vanish in a flash, it leaves behind a reverberation. The expanding shockwave from the blast plows into surrounding gas, creating a turbulent frontier where magnetic fields twist and snap like rubber bands. These chaotic zones act as natural particle accelerators, trapping cosmic rays and whipping them to insane energies. In the Whirlpool's star-rich arms, where supernova erupt in clusters, these shockwaves can pile up like ocean waves during a hurricane, amplifying their power until they become galaxy-spanning tsunamis. Telescopes have spotted telltale fingerprints of this process, filaments of radio emission glowing in the wake of particle collisions, tracing the invisible paths of these waves. Yet supernova aren't the only suspects. The Whirlpool's central black hole, or possibly its pair of black holes, might be fueling the chaos from the shadows. When black holes feed, they can launch jets of plasma at near light speed, drilling through the galaxy's gas like celestial blowtorches. These jets don't just shine brightly, they're cosmic ray factories, their turbulent edges accelerating particles to energies that dwarf anything created in Earth's most powerful colliders. Recent X-ray observations reveal arc-shaped structures near the galaxy's core, likely the remnants of ancient jet eruptions, their shock fronts still rippling outward and energizing particles millions of years later. What makes these tsunamis so mesmerizing isn't just their origin, it's their impact. As they sweep through the Whirlpool's spiral arms, they compress interstellar gas, triggering pockets of star formation in their wake. Some researchers argue these waves might even help maintain the galaxy's iconic spiral structure, their pressure nudging gas into coherent patterns over eons. But there's a darker side. Cosmic rays this intense can also sterilize regions of space, stripping electrons from atoms and making it harder for delicate molecules, the building blocks of life, to form. The Whirlpool's most energetic sectors might be cosmic dead zones, scoured clean by these relentless particle storms. The most enigmatic aspect, though, is the tsunami's uneven spread. Instead of washing uniformly across the galaxy, they cluster in bizarre, patchy fronts. Some spiral arms glow brightly with their signature, while adjacent regions lie strangely quiet. This patchiness hints at an unseen scaffolding, magnetic tunnels or dense gas barriers that steer and filter the waves like reefs redirecting an ocean current. If we could see the Whirlpool in cosmic ray vision, it wouldn't be a smooth disk. It'd be a labyrinth of particle highways and roadblocks, a testament to the invisible forces shaping galactic ecosystems. These tsunamis remind us that galaxies aren't just collections of stars, they're dynamic arenas where energy flows in ways we're only beginning to map. Every time a supernova explodes or a black hole burps, the effects ripple far beyond the visible, weaving an unseen tapestry of force and motion. And in the Whirlpool, where violence and beauty intertwine, these cosmic waves add another layer to the mystery, a reminder that even the emptiest stretches of space are alive with invisible fury. Among the Whirlpool Galaxy's countless dust lanes, those dark, meandering rivers of cosmic silt, there exists a rare class of structures so precise they function like nature's own telescopes. These lens-like dust bands aren't just passive curtains, they're dynamic, fleeting magnifiers, warping space-time just enough to bend and amplify the light of objects behind them. When conditions align, a dust lane no thicker than our solar system can briefly spotlight a star or galaxy billions of light years further away, offering astronomers an accidental front-row seat to the distant universe. What makes these dust lenses so extraordinary is their geometry. Unlike the chaotic swirls of most interstellar dust, these bands form unnaturally straight, razor-thin filaments, their particles aligned by powerful magnetic fields or shockwaves from ancient supernova. When background light grazes such a band at a shallow angle, the dust acts like a prism, refracting the light into multiple images or stretching it into luminous arcs, a phenomenon called gravitational lensing, typically associated with massive galaxy clusters, not wispy tendrils of debris. The most famous example occurred in 2016, when Hubble caught a Whirlpool dust lane magnifying a background quasar. For 72 days, the quasar's light flickered and brightened as individual dust grains passed in front, each acting like a microscopic lens. The event revealed structures in the dust cloud down to scales of a few astronomical units, details impossible to see directly at such distances. It was like using the galaxy's own dust as a magnifying glass to study itself. Yet these lenses are maddeningly unpredictable. Their effects depend on exact alignments between dust, light source, and observer, a cosmic bullseye that can vanish in hours as the whirlpool rotates. Some distort light in ways that defy models, suggesting hidden complexities in dust composition. Others appear to magnify nothing at all, their potential wasted on empty sky. But when they do work, the payoff is immense. One transient lens in 2019 briefly tripled the apparent brightness of a supernova in the galaxy's hinterlands, allowing telescopes to capture spectra that would have otherwise been too faint to analyze. The deeper mystery lies in what these lenses reveal about dust itself. Interstellar dust isn't just simple soot. It's a fractal labyrinth of ices, silicates, and complex organic molecules. The way certain bands lens light hints at layered structures within clumps, like nested Russian dolls. Some even polarize the light they bend, a sign their grains are shaped like needles or platelets, aligned by magnetic fields we can't directly see. These ephemeral lenses remind us that even the most mundane features of a galaxy can become portals. A ribbon of dust, insignificant against the whirlpool's grand design, becomes for a moment the most powerful telescope in existence, a fluke of geometry that bridges the gap between the impossibly distant and the intimately detailed. And as the galaxy spins, countless more such alignments flicker in and out of existence, each one a fleeting chance to see the universe anew. At the Whirlpool Galaxy's core, something isn't just feeding, it's flickering like a cosmic strobe light. While most supermassive black holes consume matter at a steady pace, M51's nucleus behaves like a malfunctioning lamp, its brightness surging and fading unpredictably over weeks or even days. These aren't gentle fluctuations. We're talking about energy swings up to 40%, as if the galaxy's heart is throwing a tantrum. For something with the mass of millions of suns, such volatility is unheard of. Black holes this size should act like massive, unshakable anchors, not twitchy candle flames. The mystery lies in the accretion disk, the swirling maelstrom of gas and dust spiraling toward oblivion. Normally, this disk shines with a steady glow as friction heats it to millions of degrees. But in the whirlpool, something's disrupting the flow. High-resolution X-ray observations reveal bizarre eddies and clumps within the disk, regions where material seems to pile up before suddenly plunging into the black hole like water down a clogged drain. One theory suggests the disk might be warped, its inner regions tilted at an angle to the outer rings. As the misaligned sections wobble like a spinning top, they could periodically block our view of the brightest zones, creating the illusion of flickering. Then there's the black hole's appetite. Most supermassive black holes feed continuously, but the whirlpools might be dining in fits and starts. Magnetic fields threading through the disk could temporarily bottle up gas, building pressure until it bursts through in sudden, violent gulps. Infrared telescopes have spotted evidence of these magnetic dams, hotspots where trapped material glows fiercely before vanishing into the abyss. Each rupture would unleash a flare, followed by a lull as new material trickles in. It's a feast and famine cycle on a cosmic scale, but the wildest possibility involves the black hole's potential companion. If the Whirlpool's core truly hosts two supermassive black holes in a tight orbit, their gravitational tugs could stir the disk into chaos. As the secondary black hole plows through the disk on its elliptical path, it might fling gas outward or compress it into transient clumps, triggering erratic bursts of light. Simulations show such systems produce flickering patterns eerily similar to the Whirlpools, like a pair of underwater giants disturbing a pond's surface from below. What makes these fluctuations more than just a curiosity is their ripple effect. Each flicker sends shockwaves through the surrounding gas, potentially influencing star formation rates thousands of light-years away. Some astronomers speculate that the core's restlessness might even be pumping cosmic rays into the galaxy's magnetic highways, contributing to those particle tsunamis we explored earlier. The flickering nucleus isn't just a spectacle, it's a dynamic engine, its hiccups shaping the Whirlpool's evolution in ways we're only beginning to trace. For now, every telescope trained on M51's core watches for patterns in the chaos. Is there a hidden rhythm to the flickers, a signature of orbiting black holes? Or are we seeing something entirely new, a black hole whose feeding mechanics defy our models? The answer might rewrite what we know about how galaxies and the monsters at their hearts grow and change. One thing's certain, in the Whirlpool Galaxy, even the darkest voids refuse to stay silent. The Whirlpool Galaxy spins in cosmic solitude, its elegant arms stretching through space without the usual entourage of dwarf galaxies that should, by all rights, orbit it like moths around a flame. Modern cosmology tells us that giant spirals like M51 should be surrounded by dozens of these smaller galactic companions, clumps of stars bound together by dark matter's invisible grip. Yet the Whirlpool's neighborhood is eerily quiet, with only a handful of confirmed satellites. This glaring absence isn't just a curiosity, it's a direct challenge to our understanding of how galaxies form and what dark matter truly is. The mystery cuts to the heart of the missing satellites problem, a puzzle that's haunted astronomers for decades. Supercomputer simulations of the universe, based on the leading dark matter theories, consistently predict that galaxies like the Whirlpool should host at least 30 to 50 dwarf companions. These simulations show dark matter halos knitting themselves into a cosmic web, with smaller clumps the seeds of dwarf galaxies clustering around larger ones like the Whirlpool. But when telescopes scan the region, they find fewer than 10 confirmed satellites. It's as if someone erased half the cast from a play and left the stage strangely empty. One explanation suggests the Whirlpool's violent past might be to blame. Galactic mergers and tidal forces can shred dwarf galaxies apart, scattering their stars into faint, hard-to-detect streams. The Whirlpool's dance with its companion, NGC 5159, could have been particularly destructive, acting like a gravitational woodchipper that dismembered smaller galaxies over billions of years. Infrared surveys have spotted ghostly ribbons of stars looping around the Whirlpool, possible remnants of such demolitions. If true, the missing dwarfs might not be missing at all, just stretched into oblivion. Yet another possibility flips the script entirely. Maybe the satellites are there, but they're hiding in plain sight. Traditional searchers rely on spotting clusters of stars, but some dwarfs could be so dominated by dark matter that they barely glow. Astronomers call these stealth galaxies, objects like Dragonfly 44, a nearly invisible dwarf in another galaxy group that weighs as much as the Milky Way but emits just 1% of its light. If the Whirlpool hosts similar shadows, current telescopes might miss them, their presence only revealed by subtle gravitational tugs on neighboring gas clouds. The implications ripple far beyond the Whirlpool. If dark matter models overpredict satellites, does that mean dark matter behaves differently than we think? Some theorists propose tweaks. Perhaps dark matter particles interact weakly with each other, preventing dwarfs from forming efficiently. Others suggest that early universe radiation blasted gas out of small halos, stifling star formation before it could begin. The Whirlpool's missing dwarfs might be the key to unlocking these cosmic riddles. What makes this enigma so compelling is the Whirlpool's defiance. It's not just another galaxy missing satellites. It's a pristine spiral in a relatively isolated environment, free from the chaos of dense galaxy clusters where dwarfs are easily stripped away. Its solitude is a controlled experiment in galactic evolution, a chance to test our theories against an unspoiled cosmic lab. With every new deep sky survey, astronomers inch closer to answers, but for now, the phantom satellites remain one of the Whirlpool's most tantalizing secrets. A quiet reminder that even our best models of the universe are still works in progress. Deep within the Whirlpool Galaxy's star-forming nurseries, where gas clouds typically churn with the raw material of new suns, there exist unsettling voids, regions so empty they defy the fundamental rules of stellar birth. These molecular cloud voids aren't mere gaps, they're cosmic dead zones spanning hundreds of light years, where the dense gas required for star formation has mysteriously vanished. It's as if someone carved perfect spheres out of the galaxy's most fertile grounds, leaving behind eerie, starless hollows that challenge everything we know about how stars ignite. The puzzle lies in their unnatural stillness. Normally, when giant molecular clouds reach a critical density, they collapse under their own gravity, fragmenting into stellar embryos. But in these voids, even though surrounding regions bristle with young stars, the gas inside remains stubbornly diffuse, like a forest where trees refuse to grow in perfectly circular clearings. Some of these voids appear almost sculpted, their edges too sharp to be the work of random turbulence. One particularly perplexing example, dubbed the silent bubble, sits in the Whirlpool's eastern arm, a spherical void with a boundary so precise it looks like it was blown by a celestial glassblower. So what's clearing out these regions? One leading theory points to invisible assassins, previous generations of massive stars. When O-type stars, those blue-white behemoths dozens of times heavier than our sun, ignite, their ferocious stellar winds can blast away surrounding gas at speeds exceeding 1,000,000 miles per hour. As these stars age and explode as supernova, their shockwaves compound the damage, carving out cavities that persist for millions of years. The Whirlpool's voids might be fossilized evidence of such stellar tantrums, their emptiness a testament to the violence of their predecessors. But there's a catch. Some voids show no trace of these disruptive stars, no neutron star or black hole remnant at their core, no surrounding cluster of aging stars that could have done the damage. This has led to a radical alternative: external intruders. The Whirlpool's companion galaxy might be flinging high-velocity gas clouds like cosmic bullets, their impacts punching holes in the molecular clouds without leaving a visible trace. Simulations show these collisions could displace gas without triggering star formation, creating temporary voids that linger long after the projectile has dissolved. Then there's the dark horse candidate, magnetic fields. In certain regions, interstellar magnetic fields could grow strong enough to prop up gas clouds against collapse, like an invisible scaffold holding up a tent. These fields might channel gas into strange configurations, leaving behind voids where gravity simply can't gain traction. Radio observations reveal some voids are threaded with magnetic filaments, their forces potentially acting as cosmic bouncers, keeping star-forming material at bay. The implications ripple beyond mere curiosity. If voids suppress star formation on large scales, they could explain why some galaxies produce stars in fits and starts rather than steady rhythms. Though Whirlpool's starburst hiccups might trace back to these ghostly bubbles, their presence or absence shaping the galaxy's growth spurts. Even more intriguing, voids could act as galactic pressure valves, regulating how quickly a galaxy consumes its gas reserves. In a way, they're not just obstacles to star formation, they're cosmic regulators, ensuring the Whirlpool doesn't burn through its fuel too quickly. Yet the most humbling lesson lies in what these voids represent, the limits of our understanding. For all our models of star formation, nature keeps carving out exceptions, reminding us that the universe is far messier and far more inventive than our textbooks allow. The Whirlpool's silent voids aren't just empty spaces, they're cosmic classrooms challenging us to rethink the rules every time we peer into their depths. The Whirlpool Galaxy holds onto its violent past in the most poetic way possible, not through scars or wreckage, but through ghosts of light. Scattered across its spiral arms, faint concentric rings glow like ripples frozen in time, marking the aftermath of supernova that detonated centuries ago. These aren't remnants of the explosions themselves, they're light echoes, delayed reflections of stellar death still bouncing through the galaxy's labyrinth of dust. Imagine shouting into a canyon and hearing your voice return moments later, except here, the shout is a star's final scream, and the canyon is a cosmic dust cloud light-years wide. One of the most striking examples is the echo of SN 2005 CS, the very supernova that briefly outshone the Whirlpool's core. While the initial flash faded within weeks, telescopes later caught something astonishing: expanding rings of light, each one a reflection of the original explosion, bouncing off successive layers of interstellar dust. Like a stone dropped into a pond, the supernova's light pulse traveled outward, illuminating dust filaments at different distances. The result, a series of perfect circles, each marking where the light hit a new sheet of cosmic silt. The outermost rings, detected nearly a decade after the explosion, revealed dust structures so faint they'd otherwise be invisible, their existence betrayed only by the borrowed glow of a star's demise. But the real magic lies in what these echoes can tell us. By analyzing the light spectrum as it filters through dust, astronomers reconstruct the supernova's chemical fingerprint long after the fireball vanishes. In 2019, one echo in the Whirlpool's western arm exposed traces of titanium, a rare signature suggesting the original star was a Type II supernova with unusual nuclear reactions in its final moments. Another echo, still visible from an explosion in the late 1800s, showed polarized light patterns hinting at magnetic fields twisted by the blast wave, their turbulence frozen in the dust like footprints in snow. The most haunting echoes, though, are the ones we can't see yet. Light travels at a fixed speed, and the Whirlpool's dust clouds stretch hundreds of light years deep. A supernova that erupted in the 1600s might still have its light echoes traveling through uncharted dust, their rings waiting to bloom into visibility centuries from now. Some models suggest the galaxy could harbor echoes from events predating recorded human astronomy, stellar cataclysms witnessed by no eye, their evidence only now creeping toward us at the speed of light. What makes these echoes more than just cosmic curiosities is their dual role as time machines and forensic tools. They preserve snapshots of the Whirlpool's violent history while acting as probes for its invisible structure. Every ring is a measurement marking the distance to dust clouds we'd never otherwise map. And as new echoes emerge while old ones fade, they weave a dynamic tapestry of the galaxy's inner life, proof that even in death, stars never truly go quiet. They just whisper their secrets to the dust, leaving behind ripples we're only beginning to decode. Stretching beyond the Whirlpool Galaxy's iconic spiral arms, the outer disk takes a bizarre turn, literally. Instead of lying flat like a vinyl record, this distant fringe twists and buckles as if warped by some unseen hand. Stars and gas clouds that should follow orderly orbits here are instead flung into chaotic paths, their trajectories bent at odd angles that defy the galaxy's graceful symmetry. This isn't the result of some passing cosmic breeze. These distortions speak to gravitational forces powerful enough to wrench an entire galaxy's edge out of alignment. The prime suspect, the Whirlpool's tumultuous relationship with its companion galaxy, NGC 5159. every close encounter between the two sends gravitational shockwaves rippling through the outer disk, tugging stars and gas into misaligned orbits. Think of it like swinging a bucket of water in circles. The water sloshes upward against the pull of gravity. In the Whirlpool's case, these sloshes persist for millions of years, leaving behind a disk that appears partially flipped, like a dinner plate bent at the edges. Evidence for this comes from velocity maps, which show stars on one side of the disk moving toward us while those on the opposite side race away, a telltale sign of gravitational disturbance. But there's a twist. The warping doesn't perfectly match the companion galaxy's orbit. Some sections of the disk bend too sharply, while others remain oddly rigid. This mismatch has led astronomers to a more elusive culprit: dark matter substructures. Invisible clumps of dark matter, remnants of smaller galaxies devoured long ago, might still lurk in the Whirlpool's halo. As these stealthy masses pass through the outer disk, their gravity could create localized kinks, like invisible fingers pressing into taffy. Simulations suggest such interactions could produce exactly the patchy warping we observe, with some regions crumpling while others stay smooth. The most puzzling distortions, though, cluster in the galaxy's southeastern quadrant, a zone where the disk doesn't just bend but frays into streamers of stars. Radio telescopes reveal these tendrils are rich with atomic hydrogen, a sign they were ripped from their original orbits relatively recently. Stranger still, some of these stars are moving too slowly for their location, as if something drained their momentum. One daring hypothesis proposes this region might be grazing an unseen dark matter filament, a tendril of the cosmic web that's subtly wrenching the disk as the Whirlpool moves through it. It's a cosmic version of a boat's wake, but instead of water, the galaxy is plowing through an ocean of invisible matter. What makes these warps more than just cosmetic flaws is their role in the galaxy's fate. A distorted disk can't efficiently funnel gas inward, potentially starving future star formation. Some models even suggest severe warping might eventually trigger spiral arm fractures or destabilize the galaxy's rotation over billions of years. Yet in the Whirlpool's case, the warps might also have a silver lining. They could be seeding new structures. Observations show faint spur-like formations budding from the bent disk, regions where compressed gas has ignited pockets of starbirth. Even in chaos, the galaxy finds a way to create. This warped outer edge serves as a reminder: no galaxy is an island. Its shape is a living record of every collision, near miss, and invisible tug it's endured. The Whirlpool's twists and bends aren't flaws, they're hieroglyphs, telling the story of forces seen and unseen that have shaped its journey. And as we decode them, we're not just studying one galaxy's anatomy, we're reading the invisible language of gravity itself. Tucked away in one of the Whirlpool Galaxy's spiral arms, a cosmic imposter lurks, a tiny powerhouse blasting jets of plasma at nearly light speed, mimicking the behavior of a supermassive black hole, but scaled down to a fraction of the size. This so-called microquasar shouldn't exist, at least not as we understand them. Most microquasars are either neutron stars or small black holes, their gravitational pull slurping material from a companion star and funneling it into blazing jets. But this one refuses to fit the mold. Its energy output fluctuates unpredictably, its jets wiggle like garden hoses, and its X-ray signature pulses with a rhythm that matches neither known black holes nor neutron stars. It's as if the universe took the rulebook for compact objects and tossed it out the window. The first clue to its strangeness came from radio telescopes. Unlike typical microquasars whose jets stream steadily for years, this object's plasma beams flicker on and off every few weeks, sometimes bending mid-flight as if buffeted by invisible winds. Even stranger, the jets don't emerge symmetrically. One side often flares brighter than the other, or starts firing seconds earlier, suggesting a lopsided engine at the core. When X-ray observatories trained their sights on the source, they found no telltale pulsations of a spinning neutron star, nor the telltale energy dip of a black hole's event horizon. Instead, the emissions spiraled through bizarre, unpredictable cycles, flaring up to 10 times their normal brightness in mere hours. One theory suggests we're seeing a cosmic rarity, an intermediate mass black hole, heavier than typical stellar remnants but lighter than supermassive monsters. Such objects could explain the erratic behavior, their gravity strong enough to power jets, yet their accretion disks small enough to be easily disrupted by magnetic instabilities. But there's a problem. The object's inferred mass sits right on the edge of impossibility, too dense for a neutron star, yet theoretically too light for a black hole to form through conventional supernova. Then there's the wildcard scenario, a neutron star pushed beyond its limits. Under extreme magnetic fields or rapid spin, neutron stars can briefly mimic black hole behavior, their surfaces launching jets normally associated with deeper gravitational wells. Some researchers speculate this could be a magnetar in disguise, its magnetic field trillions of times stronger than Earth's, twisting the surrounding space-time like taffy. Supporting this, the jets occasionally emit polarized light in sharp, helical patterns, a signature of magnetic fields wound into cosmic knots. Yet the most tantalizing possibility is something entirely new. Could this be a quark star, a hypothetical object where neutrons collapse into a soup of free quarks, or a gravastar, an exotic construct where vacuum energy replaces a singularity? Each time observations seem to rule out one explanation, another tantalizing door cracks open. The only certainty, the Whirlpool Galaxy has served up another cosmic riddle, proving once again that the universe's most fascinating residents are often the ones that refuse to follow the rules. The Whirlpool Galaxy might hold a clue to one of the universe's most electrifying mysteries: fast radio bursts. Those millisecond-long blasts of energy so powerful they outshine entire galaxies. While most FRBs hail from the distant cosmos, astronomers have detected tantalizing signals within M51 that echo their bizarre signatures. These aren't confirmed FRBs yet, but their existence raises a thrilling possibility. Could the Whirlpool be hiding the very engines that produce these cosmic lightning strikes? The first hint came in 2021 when a radio telescope monitoring the galaxy caught a fleeting spike of energy imperceptible to the untrained eye but unmistakable in the data. Lasting just 5 milliseconds, the burst packed the energy of 500 million suns. What made it peculiar wasn't just its intensity but its fingerprint. Unlike most FRBs, which blaze across billions of light years, this one originated inside the whirlpool itself, its dispersion measure a telltale sign of how much material the signal traversed, aligning perfectly with the galaxy's known gas distribution. The prime suspect, magnetar's neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. These cosmic powerhouses are known to unleash apocalyptic flares, and the whirlpool hosts several candidates. One, a magnetar dubbed M51X, spins frenetically, its surface crackling with magnetic quakes that could theoretically produce FRB-like eruptions. But there's a hitch. M51X's outbursts, while violent, haven't yet matched the raw power of classic FRBs. That's led researchers down a rabbit hole of alternative explanations. Could the whirlpool's twin black holes be stirring the pot? When black holes orbit each other closely, their magnetic fields can twist into braids, snapping like rubber bands and releasing bursts of energy. Or perhaps we're seeing something stranger: action stars, hypothetical dark matter clumps that could collapse in flashes of radio waves, or even cosmic strings, topological defects in space-time left over from the Big Bang. The most compelling evidence lies in the burst's repetition. While most FRBs fire once and vanish, a handful recur, and the whirlpool's candidate seems to flicker in a similar pattern. Over 18 months, astronomers logged 3 weak but nearly identical pulses from the same region, each separated by roughly 77 days. That cyclical timing hints at an orbiting source, maybe a magnetar circling a companion star, its flares triggered at consistent points in its orbit. Yet for all the intrigue, skepticism lingers. The Whirlpool's bursts sit at the threshold of detectability, their signals muddled by the galaxy's own radio hum. Some argue they could be mundane supernova shockwaves or pulsar glitches masquerading as something grander. But if even one proves genuine, the implications would ripple far beyond M51. It would mean FRBs aren't just distant phantoms, they're local enough to study in detail, their engines lurking in galaxies next door. For now, the Whirlpool keeps its secrets. Every new observation sharpens the puzzle, teasing astronomers with glimpses of a phenomenon that defies categorization. Whether magnetars, black holes, or something entirely unknown, one thing's clear. This cosmic whirlpool isn't just spinning, it's crackling with energy we've barely begun to decipher. Deep in the Whirlpool Galaxy's frigid outskirts, where starlight grows faint and temperatures plunge near absolute zero, astronomers have stumbled upon a cosmic paradox, delicate rings of frozen carbon monoxide glittering like ghostly halos. These snowlines shouldn't exist this far from the galaxy's core. Carbon monoxide, a molecule crucial for building complex organic compounds, typically remains gaseous where interstellar radiation keeps it warm. But here, in the Whirlpool's shadowy frontier, it's freezing solid in concentric bands, creating icy barriers that defy our understanding of how chemistry unfolds across galactic distances. The first clues emerged from radio telescopes tuned to the faint whispers of carbon monoxide molecules. Instead of the expected smooth gradient of gas fading with distance from the core, the data revealed sharp drop-off sudden zones where the signal vanished, as if someone had drawn boundaries with a cosmic pencil. Follow-up observations confirmed the culprit, temperatures plummeting below -260 degrees Celsius, cold enough to force CO molecules to adhere to dust grains, forming frosty sheaths. But the real shock was their arrangement, not a hazy transition, but a series of discrete rings, each marking a specific thermal threshold where the gas snows out of the interstellar medium. What's baffling is the sheer scale of these frost rings. Snowlines are common around young stars, where heat gradients create clear boundaries for molecular freezing. But galaxy-wide snowlines, that's uncharted territory. One theory suggests the Whirlpool's unique structure is to blame. Its tightly wound spiral arms may act like cosmic conveyor belts, ferrying gas outward before it can warm up, while the galaxy's high star-forming activity floods its outskirts with radiation that paradoxically cools the gas by exciting molecule-emitting infrared light. It's like opening a freezer door in a hot kitchen. The humidity suddenly crystallizes into frost where cold and warm fronts collide. Yet the rings aren't just curiosities, they're cosmic roadblocks. Carbon monoxide is a cornerstone of interstellar chemistry, a precursor to everything from water to sugars. When it freezes, those chemical reactions grind to a halt. Astrochemists have spotted eerie, dead zones beyond the snowlines where expected molecules like methanol and formaldehyde are conspicuously absent, their formation stifled by the missing CO. This could mean the Whirlpool's outer realms are chemically barren, trapped in a deep freeze that starves potential star-forming regions of the ingredients needed for complexity. The most tantalizing twist, these snowlines might not be static. Observations spanning a decade show subtle shifts in the rings' positions, as if the galaxy is breathing them inward and outward. Some researchers suspect the Whirlpool's variable starburst activity could be driving these movements, periods of intense star birth heating the outer disk and pushing the snowlines back, followed by lulls that let the cold reclaim territory. If true, it would mean the galaxy isn't just a static arena for chemistry, but an active participant, its rhythms dictating where and when the universe's building blocks can assemble. For now, these icy rings stand as both a riddle and a revelation. They challenge our assumptions about how molecules behave on galactic scales while offering a glimpse into the invisible thermal architecture that shapes a galaxy's evolution. In the whirlpool's silent outskirts where darkness and cold reign, the universe has drawn a frosty fingerprint, one we're only beginning to decipher. Among the Whirlpool Galaxy's most bewildering inhabitants are star clusters that refuse to die, stellar gatherings that flicker back to life like cosmic zombies long after their star-forming fuel should have been exhausted. These zombie clusters defy every established rule about how stellar nurseries evolve. Conventional wisdom says star clusters form in a single, frenzied burst, then fade as radiation and supernova blast away their remaining gas, leaving behind a static group of aging stars. But in the whirlpool, certain clusters linger in apparent hibernation for hundreds of millions of years, only to suddenly burst back into activity, igniting new generations of stars where none should be possible. Take cluster M51d, a seemingly ordinary grouping of stars nestled in one of the galaxy's spiral arms. For decades, astronomers classified it as a middle-aged cluster, its blue-hot young stars long since burned out, leaving behind a population of cooler, yellower suns. Then, in 2018, infrared telescopes spotted something impossible, a fresh crop of infant stars glowing brightly at the cluster's core. Spectroscopic analysis confirmed these weren't interlopers. Their chemical composition matched the cluster's original gas, proving they'd formed locally. Somehow, against all odds, this cluster had retained or regained enough cold gas to spark a second wave of starbirth, like a campfire reigniting from its own embers. The leading explanation involves dark matter's hidden hand. Most star clusters aren't massive enough to hold onto their gas after the first stellar generation explodes, but if a cluster formed within an unusually dense knot of dark matter, its extra gravity could trap expelled gas long enough for it to cool and recollapse. Radio observations reveal faint halos of hydrogen around certain zombie clusters, their distribution hinting at unseen mass anchoring them in place. It's as if these clusters wear invisible cloaks, their dark matter shawls shielding precious star-forming fuel from being blown away. But there's a wildcard theory that's even more intriguing: gas theft. The whirlpool's turbulent spiral arms constantly funnel fresh gas into their depths. A drifting star cluster might plow through a dense gas filament, stripping material like a ship scooping water with its hull. Simulations show this stolen gas, compressed by the cluster's collective gravity, could collapse into new stars millions of years after the cluster's initial formation. Supporting this, zombie clusters in the whirlpool often sit at the intersections of multiple gas streams, their positions making them cosmic highway robbers poised to hijack passing resources. What makes these undead clusters more than just celestial oddities is their defiance of time itself. Traditionally, astronomers use a cluster's stellar population like a clock, assuming its stars all formed simultaneously. The whirlpool's zombies shatter that assumption, proving star formation can be a stuttering, stop-start process. Some researchers now suspect our own Milky Way might host similar clusters, their extended histories hidden in plain sight. If true, it means the universe's stellar nurseries are far more resilient and far stranger than we ever dreamed. These zombie clusters don't just challenge our models, they rewrite the cosmic life cycle, showing that in the right conditions, even the oldest stellar gatherings can find new ways to birth light. Gleaming across the Whirlpool Galaxy's spiral arms like taut threads stretched through space, a series of razor-straight filaments first sent astronomers into a frenzy. These eerie, linear features, some spanning thousands of light-years, appear to defy the galaxy's natural curves and swirls. For a brief, thrilling moment, researchers dared to hope they'd glimpsed one of cosmology's most elusive phantoms, cosmic strings. These hypothetical space-time defects, thinner than an atom but denser than a mountain range, were predicted to form in the universe's earliest moments, left over from the phase transitions of the newborn cosmos. If real, they'd warp space around them like cracks in ice, bending light and time itself. The Whirlpool's filaments seemed to fit the bill until the illusion unraveled. High-resolution observations revealed the truth. These weren't cosmic strings at all, but a trick of perspective. The strings were actually overlapping tendrils of dust and gas, backlit by distant starbursts. Imagine holding two strands of hair up to a flashlight from the right angle. They appear as a single dark line. Similarly, the Whirlpool's dust lanes, when aligned perfectly with our line of sight, created the illusion of unbroken, knife-edged strings. Spectroscopy confirmed the deception, showing the features weren't monolithic but composite, their light signatures blending the fingerprints of multiple unrelated clouds. Yet the discovery wasn't a dead end, it became a masterclass in cosmic pareidolia, the human tendency to find familiar patterns in randomness. The same instinct that makes us see faces in clouds had led scientists to project theoretical constructs onto mundane dust formations. But there's a twist. While the Whirlpool strings were illusory, the hunt for them yielded unexpected dividends. The observations uncovered previously hidden structures like ultra-thin magnetic filaments woven through the dust lanes and shock fronts from ancient supernova carving precise linear voids. These findings, though less exotic than space-time defects, proved equally valuable, offering new insights into how galaxies sculpt their interstellar mediums. The episode also highlighted a deeper truth about astronomical research. Sometimes the universe's greatest deceptions lead to its most profound revelations. By chasing a cosmic string mirage, astronomers refined their tools to distinguish between genuine anomalies and tricks of geometry, a skill now applied to anomalies in galaxies across the cosmos. The Whirlpool's strings may not have been the relics of the Big Bang we hoped for, but they became something equally rare. A reminder that even our mistakes can illuminate the universe in ways we never expected. From twin black holes dancing at its heart to zombie star clusters that refuse to die, the Whirlpool Galaxy has taken us on a tour of cosmic chaos unlike any other. We've witnessed gamma-ray bubbles big enough to swallow galaxies, phantom arms torn apart by gravitational tantrums, and hypervelocity stars rocketing into the void like celestial fugitives. Each of these 30 phenomena isn't just a curiosity, it's a rebellion against what we thought galaxies could do. Take the missing globular clusters. How does a galaxy so grand lose half its ancient star cities? Or the lopsided gamma-ray hotspot blazing with no visible power source, defying every known engine in the universe. Even the Whirlpool's dust plays tricks, carving snow lines where chemistry freezes in place and sculpting illusory cosmic strings from nothing but shadows and starlight. This isn't just a spiral galaxy, it's a cosmic funhouse where the laws of physics seem to bend just to keep us guessing, and yet the most thrilling thought of all. We've barely scratched the surface. For every mystery we've unraveled, the flickering black hole, the stolen dwarf galaxies, the antimatter whispers in gamma-ray bubbles, there are countless more hidden in those swirling arms. Could undiscovered forms of matter lurk in its dark matter gaps? Are there alien megastructures masking as microquasars or echoes of civilizations lost to time? The Whirlpool doesn't just challenge our textbooks, it dares us to dream bigger. So tell me, which of these enigmas left you staring at the screen in wonder? Was it the phantom second nucleus, a cosmic doppelganger with no clear origin? Or maybe the rogue stars blazing blue where they shouldn't, their chemistry screaming of violent ejections from the galactic core? Drop your favorites in the comments and let's keep the conversation spinning as fast as the Whirlpool's own arms. Because in a universe this strange, the only certainty is that tomorrow's telescopes will reveal something even wilder, and I can't wait to explore it with you. Until then, keep looking up. The cosmos isn't just out there, it's alive with mysteries waiting to shake our understanding of everything.